So if you've been following along in this series, the last thing I talked about doing was potentially refactoring my code to make it more parallel using these like workers. I did that work and it turns out that it really didn't improve that much. So in this example, I uploaded 10,000 NFTs and it took about 6.8 minutes to finish all them, right? And like what I basically did was on the back end, I started up with using PM2. I started up like, I think it was 4 or 8 different services. So I have like a workers/index file that is basically ran separately. It's a separate Express application. It takes in one request to an endpoint, and based on what's sent in, it'll generate and compute a couple of NFT images, right? It does like batch processing. And I can kind of show you some of the code if that's interesting to you. But okay, so in the worker, we have a Express app that has a single NFT endpoint, right? So if I go back to the diagram, that is these little orange/red circles, okay? So it takes in a request, and it's going to basically get a list of events, some config, and an output path. And what it does is it loops over the events, creates a bunch of images, creates a bunch of metadata, puts it all in the output path, and then returns to the initial person who made the request, right? So this is a blocking Express endpoint. And the code was basically just pulled from the other parts of the project where it just loops over the NFTs and, gets the canvas, draws to the context, loads up the images, creates the metadata file, and then writes those both to disk. So the logic is pretty straightforward. I do have this sitting around. I don't need this anymore. Go ahead and clean that up. But after it does all that, it's going to send back a response, right? So I thought this would run really quick. So let me also show you the green circle, right? So there is an initial Express API that takes a request of the zip file, extracts it, gets the configuration, gets all the layers, and that is going to eventually generate all the NFT DNAs like I talked about in the last video. So kind of like generates the DNAs, and it pushes a bunch of things into this events array, right? So we have like the layer information, the DNA, I don't even know why we passed this, it's not too useful, and then the addition. So that's NFT 1, 2, 3, 4, 5, etc. So down here, I'm using Lodash to chunk up that array into 8 different segments. And then I make 8 separate post requests to these 8 separate worker nodes. Okay. So this process takes about 6.8 minutes to finish 10,000 NFTs, create a zip file, and send it back to the user, which is a lot slower than I thought it was going to be. I thought having all these workers would be a lot faster. And what I failed to understand is that I have 2 CPUs on this laptop, right? 2 CPUs and 4 threads. So even though I'm spinning up a bunch of workers, it doesn't really make any difference because I don't have enough threads to actually be able to process all of these images and create them. And then also I'm probably getting some type of disk IO thrashing because I'm doing a lot of writes. I can't for sure say if there's an issue with like the disk IO writes. I'm assuming there might be because writing 10,000 images as fast as possible to disk might be an issue. I don't even know how I would check that. If there's like a monitor or a graph I can run to see like disk IO usage to see if it's getting like hammered. But ultimately, I think the design that I picked, like I kind of mentioned in the last video, do the easiest thing you can think of and then experiment on it. So that's what I did. I did an experiment, and it turns out that this experiment is just not going to work, right? And the main reason it's not going to work is because to get a machine that has enough cores and threads gain, and especially I'm not going to have a server sitting around for an application that no one's going to use for 48 a month, right? I mean, like one person might end up eventually stumbling upon this link and trying it out, but honestly, I don't think anyone's going to use this. So why would I dish out a ton of money on something that's no one going to use? So this design that I chose and talked about in the last video, it needs to be scrapped. I need to redesign this. I need to think of a different approach. And what I think I'm going to do is I'm going to utilize lambdas in S3 and maybe SQS to basically do a lot of this parallel processing. So instead, these workers are going to be lambdas. And I think just taking the code and putting it right into a lambda will be pretty easy. I don't have to do too much refactoring. I may have to do some type of like npm install in a Docker container so I can get the correct binaries. That's one issue. If you're working on a laptop, you're working on like Mac, You can't just copy your node modules into the lambda because you're going to have different binaries. So if you're doing anything that has lower level C++ bindings, it's not going to work. So I need to actually build up this project and run npm install on a Ubuntu box or something. But that won't be too hard. I just need to do that and get it deployed. Now, the difference here is that this is probably going to be pushing a bunch of events. So send layer info to SQS. So SQS is a service on Amazon that basically acts as a message broker. I talked about a message broker in the last video, but I think we're going to actually need to bring one in and use it so that this can just generate a bunch of SQS events, and then these lambdas can process them asynchronously and parallel if they want to. Now, the disk stuff is going to basically go away. In fact, this might need to be S3. I don't know. Let's see if I can search for an S3 icon. Bucket here. Here's a bucket. So this might have to be changed to an S3 icon, and I might need to download the original. Download original zip. Right, because the original zip has all the layer images, so I need to know, like, when they're generating these NFTs, I need to grab all the original layer images. So additionally, what's going to happen is that this is probably going to have to write its output or its finalized zip. So final, actually I'm going to put batch zip here. So I mean, these things are going to work on smaller batches, right? They might work on 100 or 500 NFTs at a time. And when they're done, they're going to have to upload a zip file somewhere, right? They can either send it straight back to the API, or they're going to have to upload a zip. I'm just going to keep it simple and just upload the zip when it's done to this bucket. And then at this point, what's going to have to happen is that this API is going to have to fetch all the files from S3 and extract them so that it's kind of a flattened directory with all the images and metadata, and then zip them back up again. Now, I don't know, there might be some costs involved with like taking these files and writing to S3, but I think it should be pretty cheap. Like writing data to S3 shouldn't be too expensive. Seems like the output zip was around like a gig, so you're gonna get charged for a gig of storage, and then we delete it after. So we're gonna clean it up after. And then finally, we're gonna send that back to the user. So I don't know if this approach will work either, but I have done a lot of work with Amazon and SQS and parallel processing using lambdas, and I think it should be able to process these NFTs at a much faster pace than what I'm doing locally on a laptop, and it'll probably be a hell of a lot cheaper than what I can achieve using this DigitalOcean approach. If push comes to shove, like I could just do one of these hard-coded VMs and just get it to work. But I think I'm reached the point where it's like, in order to make this user-friendly and like performant, I'm going to have to start using some more cloud infrastructure to like really get this processing. Now, this green API, like this can stay on the DigitalOcean box. I just need something really simple to be able to send events to SQS. So I think what's going to change is that instead of doing this Axios post here, I could just do like an SQS send message. That'll send the events to SQS, and then I need to deploy this as a Lambda consuming from that queue, which will process then. But the only issue is I need to then notify this green API when all the workers are done. So that's a bit of a problem. There's a couple ways I can do this. I could potentially bring in something called DynamoDB and just have like a key value store going on. I don't know if I want to do that. There's probably a way I could just query the bucket to see if like every batch has been finished yet. That might be the easiest approach. I don't really know. Just periodically just check the bucket and say, hey, is the bucket done? But ultimately, it's just, this is like a fan out, fan in approach. So there's solved solutions for this. How I've done it in the past at work is we'd have like a Dynamo table here. And I might do this because it's going to be super cheap to get going. But basically, when these workers are done, put this over here. So I'm going to basically say, when the worker is done, update batch process status. Okay. And what this can do is basically just fetch from Dynamo periodically and say like let's see. I might need to, let's see, I'm gonna change this to a 5 and say periodically check Dynamo for batch status. And then when it's done, that's when I can zip the files and send them back to the user. So yeah, that's one approach. I don't know if this is going to be additional complexity. I wanted to keep it simple. I didn't want to have to bring in more Amazon services and get charged for all these different underlying things. But I could probably just keep on querying the bucket to see if a file exists. And if every file in the batch exists, then I'm done. You know, I'll just do that. It seems like it'd be much easier than using Dynamo for right now. Again, keep it simple, experiment, try it out. So I'm going to do that refactoring, and then I'll probably come back and give you an update of how it's working. Hopefully it shouldn't take me too much time. It should be pretty straightforward. Anyway, if you enjoyed watching this little update video, be sure to give me a thumbs up on this video because it helps my channel grow. Also, be sure to click that subscribe button and bell icon if you want to see more videos like this in the future, or if you just want to follow along on this NFT-Magic project that I'm building out. And like always, if you have a comment, a question or concern, or a feature you want to see added to this project, feel free to leave me a comment. I'll read through the comments, I'll reply. And yeah, that's about it. It's funny, like I said, I wanted to get into Web 3, but what I'm actually doing right now is just working on Web 2 stuff. Just doing the same thing I've always been doing, but it's more interesting because I'm coming at it from a different perspective. So, all right, thank you so much for watching, and happy coding.